Hi, this is Nick Pizzi with another video training series. This one is entitled Cross-Connection Control for Beginners. All Ohio utilities are required to run a cross-connection control program, but not everybody that works at the utility really gets to work with the program itself. Usually it's only one or two folks there. So this video is put together just to help all the other utility people understand what is going on in the cross-connection control program. So I'm going to share this screen with you if you'll bear with me. Okay, cross-connection control for beginners. We should get to understand some of the definitions, and these tend to show up on exams for those of you operators taking a Class 1 or Class 2 exam. Some of the definitions that help understand what the cross-connection control program is all about are found here. So the definition of backflow itself is water of questionable quality or waste or other contaminants enter the public water supply because there is a reversal of flow. In other words, water that's already been used at a facility reverses its flow and comes back into the public water supply, and that is always not a good situation. For some of the other definitions called cross connections then would be any connection by which the non-potable supply can backflow into the potable water supply. Cross-connection control then is actually the program that helps physically separate the potable and the non-potable supply so that these backflow occurrences don't happen. Typically, utilities are going to use mechanical devices to stop the ability of water to flow backwards. There's the RPZ device, which is a reduced pressure zone backflow preventer. There's the DCVA, which is the double check valve assembly. There's the PVB and AVB, which are small devices called pressure and atmospheric vacuum breakers. And there's another device that we call the air gap. It's really not a device, it's just a physical separation between the public water supply and the used water supply. Of course, when you have an air gap, you lose pressure, so the people that take that water have to repressurize it, and so there's another cost of energy. We define safe air gap as the minimum distance of a water inlet opening above the maximum high water level or overflow of the rim. So think of a sink with a faucet, or maybe a bathtub with a faucet hanging down. The physical space between the top of the bathtub itself and the outlet of the faucet has to be at least 2 inches, and preferably more. Now, backflow occurrence, there's two ways in which backflow can occur. Normally, water doesn't flow from a high pressure to a low pressure. Or rather doesn't flow from a low pressure to a high pressure. So the two ways in which that can happen would be back siphonage and back pressure. Back siphonage is backflow caused by a negative or reduced pressure in the supply piping when there's a drop in the water pressure. Back pressure then is backflow caused by a downstream pressure that is greater than the upstream or supply pressure in the public water system. Can be caused by downstream pumps or whatever. So behind a cross-connection program is the simple truism that water always flows from high pressure to low pressure. So if you can maintain a lower pressure on the customer side of the water use, you'll never have backflow occurrence, but sometimes they can overcome you. So we need devices to protect ourselves against that happening. Ohio EPA has cross-connection control regulations. The law is 3745-95, which requires public water suppliers to protect the public water system from cross-connections and backflow occurrences. The public water supplier must conduct cross-connection control inspections of their water customers' property to evaluate if there are any hazards on that property. In other words, if that customer uses the water in such a way that might be a hazard, if it backflows into the public water system, you have to note that in your inspection, and you have to do something about it. Local ordinances and water department regulations may also exist, and of course has to be followed in addition to any state regulations that there are. Now, the water customer is the ultimate responsibility for properly maintaining the plumbing systems, but they don't always do that. It's the homeowners or other customers' responsibility to ensure that cross connections are not created and that any required backflow preventers are tested. So if the water utility goes out and makes an inspection of a homeowner or a business and finds that there are cross-connection problems and insists that the device has to be installed, it is the responsibility of the owner of that premises to buy and install that device and have it tested on a periodic basis according to the backflow correction program that the utility requires. Here's a couple of the mechanical devices that are often used. There's the RPZ device on one side and the double check valve assembly on the other. Note that they both have similarities. They have two independently acting spring-loaded check valves in them. Check valve number 1 and check valve number 2. You can see in both of these the flow is going from left to right. Those check valves have springs in them that are guaranteed to maintain at least 1 or 2 pounds per square inch pressure drop across them. By the spring pushing against the water, it maintains a pressure drop. And as long as the pressure drops, water can't flow from that customer back towards you. So if you have 2 chances to do that, 2 spring-loaded devices, there's 2 times the ability to protect yourself against that flow going backwards. Because as we said, water won't move from a low pressure to a high pressure. So the spring ensures that. The RPZ device that goes one step further. If you notice, it has a differential relief valve port in the middle of those 2 check valves. And that port senses the incoming pressure and the downstream pressure, and has a spring also on a membrane. And that device works to maintain at least a 2 pound per square inch pressure differential from high to low. If for some reason the customer starts pushing water back towards you, that relief port is supposed to open up and maintain that pressure by dripping water out of that device so that the pressure doesn't approach your incoming pressure. Now that's of course if the second check valve fails. If the second check valve works its job, water should never get to that relief port. But if it's broken spring or it doesn't work for some reason, maybe there's some dirt lodged on the check valve itself, then that differential relief port is supposed to open up and work. Of course, you still have the first check valve working in your favor also. So that RPZ device has really 3 chances to stop backflow from happening. The double check valve has 2. As you can imagine, the RPZ device is used in those situations where the hazard is high. We also have vacuum breakers. Vacuum breakers provide excellent protection against back siphonage, and the pressure vacuum breakers have a spring-loaded check valve, but also some inlets on them that you can use for testing the devices. The atmospheric vacuum breaker does it. Normally, these are used for just hose bibs on your house or maybe on an irrigation system. Here's what they look like. The atmospheric one is on the left. Just simply opens up. If water tries to come back against the system, it opens up and lets air into the system. When you open air into the system, you relieve the vacuum, so water can't move backwards. The one on the right has the same thing happening, but also has a spring-loaded check valve in it. It keeps water from moving backwards. Notice the test ports on the pressure vacuum breaker. There's 2 definitions that we use, and actually philosophical differences exist in utilities on how to do this, but some utilities practice isolation for backflow protection. Some use containment for backflow protection. Containment literally separates the water user from the public water supply by placing a backflow prevention device on the main service line. So most utilities are going to do this. They're just going to go out and inspect your premises. If you have a high hazard of contaminating the water supply, they'll simply contain your facility by putting a backflow preventer on the service line coming in. Whatever happens on your property is your business, but water's not going to get back towards the purveyor. Isolation, on the other hand, literally goes into your facility and looks for different water use practices that you might have. Like, for example, you might have a big factory with a boiler. So if you put a device on the boiler itself, it protects not only the public water supply, but also the workers inside the facility. So there's a difference in philosophy, containment versus isolation. And for your exams, you should know those 2 definitions. A little bit about cross-connection program. Ohio rules. By law, devices have to be tested at a frequency that are dictated by the purveyor. Record keeping, of course, Ohio requires that you track your progress by keeping test sheets and inspection reports. So when a device goes in and it's tested, you're supposed to get a report on that and keep that record of that device as years go by. You have to enforce the program. Sometimes that's a little difficult to do, but the public water supply has the power to make notifications to the customer that if they're not following the rules and regulations, it might end up with their water being shut off. And you have to actually go out and do that. It doesn't do any good to threaten to shut someone's water off if you don't actually intend to go out and do it. So many a program has to go out and shut water off from time to time just to get the message across. I'm sorry, I have the word Michigan in there, but it should say Ohio Annual Cross-Connection Report. All water systems should have a written plan that explains the cross-connection program and shows a list of intended inspections over the coming years. Here's a picture of the backflow prevention testing device, the kit that plumbers use to test these devices. And in this picture on the right, water is flowing from right to left. You can see this device has a gauge, a pressure gauge on it, but that's not a regular pressure gauge. That's a differential pressure gauge. It tests the water pressure on one side of the device and then the other, and combines them. One is higher, one is lower, and combines the two of them and shows the difference between the two, not the actual pressure itself, but the difference between the two. But for example, if that yellow hose is on the high side and it tests incoming pressure at 60 pounds per square inch, and the red hose is after the first check valve and tested at 58 pounds per square inch, that gauge would show 2, the difference between 60 and 58. But when you put this test device on there, that's exactly what you're doing. You're testing to be sure that each check valve can maintain 1 or 2 pounds per square inch pressure differential. So you put the hoses on, you open up the gauge. If there's a pressure differential between the two, you know the device is working. If the pressure is equalized, it would show a 0 reading. Then you know you got something bad about it. You got to go and fix the device. The relief port itself on the reduced pressure principle backflow prevention device also can be tested here. Now that port is supposed to be able to open and drip water or shoot water out on a periodic basis to maintain a lower pressure on the customer side. And that again is, say, 2 pounds per square inch differential pressure. So what you do with the third hose is actually push water pressure back against that relief port. When you open that up slowly and start equalizing the pressure, the device itself is supposed to open up and drip water. And that gauge should show no smaller than a 2-inch differential pressure between that. So that's how the plumber uses the test kit when he goes out and tests the device. Ohio EPA does have backflow prevention cross-connection control brochures and books that you can get. Some of the common hazards are listed in the brochure, and I recommend that each utility have at least this brochure. You can hand them out if necessary. There's a couple of slides I have following this that just show some of the common stuff that you see in here. For example, you'll see that they'll list boilers and how you should protect against them, lawn irrigation systems and how you should consider those as high hazards and because of the pooling of water around the sprinkler heads, that type of thing. They mentioned water softeners, water hauling equipment. Water hauling equipment, of course, is a big hazard for utilities. In the summertime, you see these trucks roll up to a hydrant and suck water up in order to mix up the chemicals in the tank and spray lawns down. Of course, those are hazardous chemicals. By its nature, that truck sits at a higher level than the fire hydrant. And if you have a main break or firefighting capability in the neighborhood, and they put a back siphonage situation in the situation there, you're going to suck back those chemicals from the truck. So those are things you need to protect against. So, okay, I hope that helps a little bit with the average person looking at a cross-connection control program that doesn't actually work in the program itself. We'll stop the video and get back to the system itself. Thank you for paying attention, and I hope this worked for you.